Imagine a universe completely opposite to ours. Instead of atoms, there's antimatter. Antimatter is like the mirror image of matter, almost identical but with a reverse charge. Think of it this way, if our universe is built with Lego blocks, the anti-universe uses anti-Legos. They look the same, but something's different. Everything we see, from stars to planets, even ourselves, is made of matter. But somewhere out there, could anti-stars and anti-planets exist, formed from antimatter? It's a question that keeps scientists awake at night. The universe is a vast and mysterious place, and antimatter is one of its biggest puzzles. For every particle of matter, there's an antiparticle of antimatter. An electron, with its negative charge, has an antimatter partner called a positron, with a positive charge. They are like two sides of the same cosmic coin. The existence of antimatter is not science fiction, it's a scientific fact observed in labs and cosmic rays. But if matter and antimatter are like two sides of a coin, why do we see so much more of one than the other in our universe? That's the billion-dollar question, a real cosmic mystery. The story of matter and antimatter begins with a bang. Not just any bang, but the Big Bang, the universe's explosive birth. In those first fleeting moments, the universe was a hot, dense soup of energy. From this energetic soup, particles and antiparticles burst forth in equal measure. Imagine the early universe as a giant particle accelerator, far more powerful than anything we could build on Earth. Collisions released unimaginable energy, creating matter and antimatter in equal amounts. It was a perfectly balanced cosmic dance. But this symmetry didn't last forever. As the universe cooled and expanded, matter and antimatter should have annihilated each other, leaving behind nothing but a faint glow of energy. Yet, here we are, surrounded by a universe brimming with matter. How did matter win this cosmic duel? The answer, it seems, lies in a subtle imbalance, a tiny flaw in the mirror between matter and antimatter. When matter and antimatter meet, the result is explosive. They annihilate each other in a burst of pure energy. Imagine throwing a log into a fireplace. The log disappears, replaced by light and heat. That's what happens when a particle meets its antiparticle. This annihilation process is the ultimate energy release, far more efficient than even nuclear fusion, which powers the stars. It's why antimatter is often featured in science fiction as a powerful energy source or a devastating weapon. While we don't encounter large amounts of antimatter naturally on Earth, scientists can create small amounts in laboratories. These antimatter particles, trapped within powerful magnetic fields, provide valuable insights into the fundamental nature of the universe. The study of matter-antimatter annihilation helps us understand the events that transpired during the Big Bang and may one day lead to revolutionary energy production methods. The universe is clearly biased towards matter, but why? This is one of the biggest unsolved mysteries in cosmology. Physicists suspect that a slight asymmetry, a tiny crack in the mirror between matter and antimatter, tipped the scales in favor of matter. Perhaps during the early universe's chaotic dance, a slight preference for matter emerged. For every billion particles of antimatter, maybe there were 1,000,001 particles of matter. This tiny excess, this cosmic rounding error, would have been enough to shape the universe we see today. Scientists are searching for this asymmetry in experiments at particle accelerators, trying to recreate the conditions of the early universe. They are also looking for clues in the cosmic microwave background radiation, the faint afterglow of the Big Bang, hoping to find echoes of this primordial imbalance. The answer to the matter-antimatter asymmetry is fundamental to our understanding of the universe. It's a reminder that even the smallest of imbalances can have profound consequences on a cosmic scale. The universe is full of surprises, and the mystery of the missing antimatter continues to inspire our quest to unravel the cosmos's deepest secrets.